All right, this is going to be a quick tutorial for how to use the query bot. It's a bot in the ranked server. You can see it, it's this thing here. I've been wanting to do this for a while, but I keep on putting it off because I want to put too much effort in. This is going to be unscripted. We're just going to go and go over a couple things. I'm mainly doing this because I know that I think CG's video is no longer available. And yeah, it might be useful to have a quick high-level overview of how to use the query bot for people who want the general context of it. So QueryBot is a bot that I wrote. It's a Python bot. It runs my server. And basically what this bot does is it allows you to query the match data from the ranked server, or sorry, the ranked API. Specifically, I've downloaded all of the ranked match data. And so instead of having to deal with API limitations and that sort of thing, like rate limits when you're trying to query a lot of data, you can instead just use my bot to do overall queries of the entire data set of ranked matches. Except there's a slight problem. This data set was growing to a size of over 23 gigs of Python data on my server, so I was running out of RAM, so we've restricted it to only seasons 4 and on, and I'll probably have to remove a couple more seasons unless I'm able to fix that problem in time. But for the time being, we only have matches available from seasons 4 and onwards. So seasons 0, 1, 2, and 3 are not available. That's just a slight detail, though. I don't think anybody really cares that much about old seasons right now in general. So we're just going to go over how queries work. But first off, we're just going to go over the commands that are available from the bot. So if you go into this channel here in the MCSR ranked server, I guess it's kind of cut off on here. I'm just trying to zoom in as much so we have everything available. You can click down here, rank query bot, and you can see all the commands that are available, and actually not all of them because, again, it's getting cut off. But at the top, we have average completion. We have a FAQ, some info, a variety of things. Query allows you to do dynamic queries. This allows you to write your own queries. Top activity, matchup, leaderboard, and average completion all basically are helpers that run pre-written queries that I wrote that maybe use some parameters from you so that you can do things easier without having to write a query yourself. So for example, let's take a look at query be leaderboard. So this gets you a leaderboard. We have a couple of different possibilities here. You can get the fastest completions, ELO or average completion. We'll go with average completion, whatever. So you can get the average completion for a player, specifically their position on the leaderboard. You don't have to, though. You can, otherwise it just gets the top 10. You can do it over a C type or no C type, and you can do it over a specific season or the current season, which is the default. So we're just going to go ahead and grab a C type, and we'll grab written portal. So this is really easy. You don't have to write an actual query for this. And as you can see, that generates this query for you and then runs it. And then you can see that for our query, which was Ruin Portal, current season, the leaderboard of the top 10 players based on their average completion on Ruin Portals only is this. So you can see Blind Travel has the best one, but also this extracts not just the average completion, but also their total number of completions on Ruin Portal. As you can see, this player, Blind Travel, only has 1 completion on Ruin Portal, so it makes sense. It's a lot easier to get a good average completion for in any data set. It's easier to get a good average if you only have one or two items in your data set. Let's go over how this actually works, though, next, because I don't think we need to really cover anything else about the helper commands. They're pretty self-explanatory. So I've just opened Paint over here so we can go over this a bit better. So what is ranked query language? What is a query language? So basically we have a bunch of data, right? I guess I should have drawn a diagram beforehand, but we're just going to do it on the fly. So imagine a ranked match is some data. It's players, some players, maybe it's Loki versus Dougal or something. And then you have the winner, and then maybe, I don't know, I shouldn't have selected real players because I have to choose who wins, so we'll just randomly decide it's Dougal. Let's say Dougal wins. Was it a forfeit? And this is a Boolean. Maybe it's true, maybe it's false. Sorry. And this is all data. Oh my goodness, that's super wrong. This is all data that's available in the MCSR ranked API. So for any given match, say match 3,972, you can go to the MCSR ranked API, look up that match, and you'll get all this information for that match. And what this bot does is allows you to query all of that match data for all matches that have occurred in the current season or in previous, etc. We already went over this. So basically, so let's say we have this match. Let's say we have a player that we're interested in, right? Actually, that's not really that useful because we're looking at this query here. So this is an example query. And basically, you can think about a query as kind of a supply chain, not a supply chain, maybe like a factory line in a factory, right? So in a factory, you kind of have this factory thing. You have items that go through the factory, and as they come to each station in the factory, something happens to the item. So maybe maybe the item comes through, and this person says, "Oh, I think that we're gonna put a little bow on the items." Now that's not a bow. It's with a mouse. Okay, we're in Paint with a mouse. I'm so sorry. So now this item goes over here, and this person, maybe they like tie the bow. So now the bow is like tied, right? And it's really nice. And then maybe this person, they like paint the box white or something. Then this person, because this analogy isn't very good, maybe this person is like, you know, maybe they come from the factory and some of them are damaged. And this person is like, we remove all the damaged ones, but only the ones that are good keep on from here. That's basically, you can basically think about a query like that. So essentially, we have these pipe symbols. I guess most people aren't familiar with Unix terminology. This here is a pipe, okay? This here is a pipe, and basically anything after a pipe, there's an implicit pipe at the start. That's just a language implementation detail that nobody cares about. But anything that's after a pipe until the next pipe, so here, man, it's really hard to do this with a mouse. So anything that's after a pipe, including the implicit first pipe, you can put a literal pipe there. Nobody ever does, because I never did it, so nobody knows that you can. It doesn't matter. It does nothing. Everything that's after the first pipe until the next pipe. So you see here, we don't end with a pipe. So then it's, oops, oh my goodness. That's, maybe I should lower my DPI for this. Anything after a pipe until the next pipe, if there is a next pipe, is basically one station in your factory, okay? And what happens is that the items are all of the data that you're working on. So all the data comes from the left here. It's left to right. And then you have your command, right? And then you have your parameters for the command. There can be one or more parameters, or zero or more parameters. Right. So you're always going to start with the command. So commands are, we're going to call commands functions because that's what they're called in the bot, and that's actually what they are. So if we do a query and we type in all funcs, there's a couple different things that don't actually operate on data. So all funcs doesn't do anything with your data. It's not a command in the sense that like it's going to transform your data somehow, but it does get you a list of all the functions. So you have commands like splits.filter, count uniques, debug echo. I don't even know what that does, to be honest. We could check the code, but we're not going to. And so essentially, these are all the different functions, all the different commands you can put in here. So this filter could be anything else. And as you can see, filter is in here somewhere. Is it? There we go. Yeah, so you can see filter, and then we have filter 2. What does filter 2 do? I don't know. I don't remember. That was like probably over a year ago. And so essentially, what happens is that, so say all your data is coming in here. So implicitly, you get the current season. You can write an index command. So you can write index, say S3, or not S3 because there isn't a season 3 in the data set. But you can say index S4 at the start, right? And then this will change it so that you're using index of season 4. In fact, what it really does is it loads the data from index season 4. So you can kind of think about it like we're getting a little into the weeds here. I'm so sorry. But say basically you have a query, right? And you have your data. Your data right now at the start of your query is all of the data from the current season, which I'm pretty sure we're on season 6, right? I'm not sure. I think it's in season 6. So basically it's the same as if you write index S6, right? And then you write a pipe to go to the next command, essentially. But you don't have to. You can just write index season 6, and it'll just print the matches from index season 6, right? Because that's essentially what this does, is if you don't do a specific, the way the bot works when it's evaluating your query is that if you put in a command, if it ends at a command, but it didn't end at a command that actually prints something, so like count or something like that, which just counts the current objects, if it just is some data, it'll just print the data. And in this case, because there's so much data, there's 236,000 pieces of data. Obviously, you can't print all that in Discord. So what it'll do instead is it'll just give you the first 10. But whatever the data is, it'll just give you the first 10 of that data. But otherwise, if you do something like count, it won't do that. So say you do index S6, and then you pipe that into, pipe that into, because it's Linux terminology, but it really doesn't matter. As you can see, you no longer get this output. We still, at the end here, at the end of count, because we didn't modify the data, this is actually just a printer command. This is, I don't know, we're going way too in depth on this. I'm so sorry. This is actually just a printer command. It prints this, but because we printed as our last thing, it doesn't give us the data. What we can actually do, if you want, you can do something like this, right? Index S6, count, and then index S6. And I'm just doing this to show, now we have the data again. We print the current size when we go here, but then when we get to index S6, this actually reloads the data set, right? And then it gives us, and then we end up with this data because we no longer ended with a printing command. So essentially, we start with some data, and then we're transforming it. And what you can do is you can always reload a blank slate data if you want to by using an index command. which will get you back original data essentially. So for example, what you could do is you could do query index S6, but this actually does nothing, so we don't have to do it. It's not useful. You can say count the current number of pieces of data, and then say we'll do a filter. So let's talk about filter. So you see filter here, filter seed type shipwreck. Basically, this programming language really sucks, and I'm sorry about that, but this is just the way filter works. Filter, what filter does is it allows you to filter for something, so it's a positive match. So if we do filter seed type, say we're in Portal, this will only give us, this will take in whatever came from here, right? Because your stuff's moving down the assembly line. Whatever that is will come in here. And filter says, hey, if the seed type of whatever just came in here is ruin portal, it can go through. Otherwise, it can't go through. Same as like our damaged package analogy. So you filter seed type ruin portal, and this basically gives you just the things that are ruin portal. Pretty simple, I think. It's just, this is just the way it works. There's a couple other things you can filter for. So let's talk about attributes, actually. So basically the entire way that this language works is essentially we have a couple different object types. We have players, we have matches, and then we have some stuff with timelines that I'm not going to go into detail about. And the data that you can currently be working on can be one of those different data types. So you can have, it's essentially a huge, like this stuff here, hold on, where is that? So this stuff here that's going through your assembly line can be one kind of data type, generally speaking, at one specific point in time. So here you have like your entire list of things that goes through your assembly line. This can all be matches. At the start, it's always matches because that's just how it works. Index S6 is going to be the current season. Well, the current season is index S6 right now, and that's what you get at the start. That's just a list of all the matches from season 6, and those will go in here. But if you go and you say, hey, I actually want players. I don't care about match data. You can just use the players command, and now everything that's in here is now player data instead of match data. Essentially, if you do players, before this pipe, we'll add the explicit pipe so that's very obvious. Before this pipe, all the data that we're working on is going to be all match data. It's all the different matches. Then it goes into players, and players is just a special command that converts that match data into players, player information from all those matches. And now all of our data that comes out on the right side of the command, essentially, you can kind of think of it as like a pipeline. That's what it is, literally, I guess, is all player data. So now say we want to extract everybody's ELO, or maybe say we want to just have a very simple leaderboard command. We can just get the ELO and we can sort by it. So we can do an R sort, which is a reverse sort. Reverse sort sorts the largest number first. Normal sort sorts the lowest number first. That's just how sort normally works. We sort ELO. We've literally just written our own ELO, our own ELO leaderboard, essentially. And as you can see, Loki is number 1, Dougal is number 2. There you go, etc. But you can also, you could remove these first like 50 players if you wanted to get the position on the leaderboard at some other point. And essentially, ELO is an attribute of a player. ELO is not an attribute of a match. Anyways, so attributes. So we already saw if I do a query of all funcs, this gets us a list of all the different functions. And most of these functions, not all of them, but most of these functions say filter or round or, I don't know, average by or extract. These all work with attributes on the current data, okay? So basically your data set comes in and they do something with the data, but specifically attributes on the data, and then the data comes out. Maybe it's changed, maybe it's not. So let's do something really, really, really simple. We'll do a query, and then we're going to say, hey, extract winner, okay? So if you remember, we're going to start with the current index, so the index of the current season, only the ranked matches. That's going to go into extract winner, and then what's going to come out is all the winners. There you go. Very simple. It's literally just a list of the winners, because what we did is we used the extract command, which just takes some piece of data out. It takes the data that we have and basically reduces it down to just the attributes that we want. So all of the matches are coming in here, but for every match, we're only going to take the winner out of them because winner is an attribute on the match. And it's very useful to know how to get a list of all the attributes in the current data type. So we're just going to show that. Attrs gets you the attributes. So as you can see, it does tell you the current data, the data type, which is quite useful. And this says the known accessible attributes of query match. So this is a match because this just works on the previous data that was passed into it. So this does actually like track the data that comes into it, right? So the query matches went in, and this tells you what the accessible attributes of a query match are. And you can use the ID, the seed type, the type. I don't actually remember what type is. Winner, members, duration, whether or not it's a forfeit, season, category, date, whether or not it's a decay match. So when somebody just loses 5 MR for not playing enough. Timelines, which we're not going to talk about. I don't actually know what score is. Has elos is a long story. We won't mention that either. And a couple other random things. And the Bastion type, which is also pretty useful. So if you want to know what any of these look like, what you can do is you can just say, hey, like I want to know what kind of seed types there are. So I'm going to go ahead and do query. And then we know that when we start off, we have all these attributes available because we just did attrs on a starting off position. And we can just extract the seed type. But this isn't super useful because now you have to search like, oh, buried treasure is a possible seed type, shipwreck is a possible seed type. I just really want the different ones. There is a helper, goodness. There is a helper for that as well. You can do extract seed type, which now you only have the seed types for all the matches. We can just do count uniques. And what this does is it takes everything that comes in and it'll give you the unique counts of each of them. So these are seeds that didn't have a seed type. I think this was before seed type was added to the API. And then we have buried treasure, shipwreck, village, ruined portal, desert temple. So those are the possible seed types that you can filter for. Right, so the next thing, we're just going to talk about player attributes because we should go over that real quick. There's a lot of stuff going on there. So if we do query and then players, if you remember, we convert all of the data that comes into players. All of it that comes out is actually only just the player data. It basically completely rewrites our data set. So like with this, we kind of get a one-to-one mapping, right? Every single match that comes in becomes a seed type because every match has a seed type, even if it's none. But in this case, the data that comes out is very different from the data that goes in. And then we're going to do attrs on that. And as you can see, these are all the attrs of player data type, clunk players, player. And a lot of these are not that useful, so I do apologize for that. But RQL ones are pretty helpful. These are basically magic methods. It's a long story. But basically, if you remove the RQL from the ones that are RQL, so say RQL average completion, we know that if we extract average completion, this will do something magical and it'll probably be nice. So if we do query, players, extract average completion, you can see that we get the average completion out. And these are all pretty formatted as actual times. And it's a long story, but basically anything that starts with RQL underscore is a function that you're allowed to call from within the language. It's essentially nested functions. It's just magic. Don't worry about it. But what you have to do if you want to use any of these attributes is you have to remove the RQL underscore and then use the rest of it. So say total time or total time gets you, I think this is the total amount of time that someone's played ranked. So if we do players, extract total time, and then say maybe the nick. So I didn't mention this before, but of course you can extract multiple things. You don't have to only extract one attribute. You can extract multiple. This turns into a tuple. That's the Python term for it. I don't know if there's really a good term for it otherwise, but essentially it's no longer a special data type. It's just a generic data type that contains just the total time and the nick, and there's no other information because that's all we extracted. But you can index into it using a number. So you can say, hey, I want to sort. Actually, rsort is probably better here. I want to rsort on 0. I think it's 0 index. I don't actually know. Oh my goodness. So this is actually maybe a good example of error messages that aren't super useful. So this is just giving you the Python error message of what happened when it was trying to run your command. It says less than is not supported between instances of method and method. The reason why is probably because index 0 is the total amount of playtime, but for some reason we're extracting the function total time and not the value. So it's trying to compare functions, which just doesn't really work. And that's totally useless. So I don't know if there's a way for me to fix this in this query. Yeah, total time is already a function. Well, no wonder that doesn't work. Oh, well, I guess that works. So I guess you don't actually have to prefix it with RQL. All right, so we're going to extract the RQL total time because this is more explicit, apparently, and it is supported according to the code. Very useful. And then we will do an rsort on 1. And that's not the right way to sort this. Super useful. It's 0 indexed. So the first item is numbered 0, which is maybe not the most intuitive thing, but whatever. As you can see, vstrt has 409 hours, then Ferris cube with 358, etc. And this is just this season, of course. Yeah, so I actually don't really know how much further we're going to go with this. We'll call this version 0. I don't think that this is necessarily the most helpful video ever, but at least it's a video, and we've kind of started moving in the documentation direction. One other thing I'm going to show you is help. So of course you can do all funcs, and this gets you a lot of different attributes, but you're probably wondering how to actually use them. But I did actually write documentation for most of these. So if you do a query and you say help, say for example, all funcs, this gets you the information for that function. So if we do a query and we say help, I don't know, something that we haven't used, say average by, this will print basically the functional notation of what you have to use in order to use that function. So this is average by to average by. So unfortunately, just the way the syntax works, this gets converted to average by, goodness, average by to average by, right? So if you're going to do this in a query, it would look kind of like this, right? Average by, and then whatever your thing you're averaging by, average by, compute the average value of an attribute. I don't actually know how this works. This is old. Compute the average value of an attribute across a data set by the value of the second attribute. Oh, that's really cool, actually. Yeah, this is basically a grouped average. So if we say average by duration seed type, this would actually get us, let's actually do that as a query. That's cool. Yeah, so the average buried treasure time is 10:38, the average shipwreck time is 11:03, the average village time is 12:03, etc. There you go. So I didn't know how to use this, and then we read this and it works. But the reason why I was showing this is because you just have to understand that when you see this in the help, average by, and then the parentheses, these are the arguments, and then this is the function name. And the way that it works in the actual language is that the arguments are just given space separated after the function name. So average by, and then we average the duration by the seed type. So this was this, and then this was this. Yeah, and I think with that, that's actually a lot of the information you should need to use this. But yeah, I should mention that anything to do with like changing or storing data is pretty hard to do with this bot. It's really made for just like distilling down data and making like summary data. It's not going to be so helpful for things that would require like complicated code to write normally. Yeah. Anyways, that's about it. I'm going to cut this video down a little bit and then just put it up, but I'll try and make a better version at some point. This is just kind of like a, we'll call this version 0.